I'm going to take a brief look at some of the most famous meteorites with you. Perhaps the most famous is one called Murchison, fell in 1969 in South Australia, well, in Victoria actually, the southern part of Australia. And also Allende, which fell in Mexico the same year, about 6 or 7 months apart. Now, this is a little weathered piece of Murchison, and this is a nice fresh one. Shortly after it fell, people got out and got finding pieces of it. There's a lot of it. You could perhaps buy that piece today, or one much like it, for maybe $60,000, maybe $100,000, something like that. It's a chondrite. Why is it worth so much money? Well, the backstory. It's one of a particular class of chondrites called carbonaceous chondrites, CC for short. Now, these don't have any more carbon in them than many other meteorites. Even some iron meteorites have a bit of carbon in them. Might be in the form of silicon carbide, might be in the form of diamond. Usually microscopic diamonds, though there are bigger diamonds found in the odd one. There are diamonds found in a number of the stony meteorites, particularly the chondrites. Small diamonds and never good enough to be considered as gemstones. Murchison, along with Allende and with several other of the carbonaceous chondrites that have been analyzed, contain organic compounds. Now, an organic compound doesn't mean life. It doesn't mean that there's anything biological there. An organic compound in the world of chemistry is anything that is made of a mixture of carbon, hydrogen, oxygen, and nitrogen. Well, that's what we're mostly made of. And that's what all life forms are mostly made of. And that's what a thing called amino acids are made of. Amino acids are the base unit of all life on our planet, and presumably will be the base chemical unit for any other life we manage to find in our solar system, should we ever find any. This Allende fell in a very rocky area, and most of the pieces chipped and cracked and broke when they landed. So this is a kind of a fresh broken surface, a kind of, you can see the whitish colored chondrules. There's some other white objects in there I'll mention in a moment, but the rest of it's sort of a dark gray. Well, the Murchison has had the most chemical work done on it, though Allende's not far behind. It's not worth doing very much of this detailed chemical work on the other carbonaceous chondrites because they weren't found close enough to their landing time to avoid earthly contamination. And if we're looking at organic compounds, well, Earth's got organic compounds all over the place, even in deserts. There's some. So this contamination would make a mess of trying to do anything with the others. Well, so far, the organic compounds in Murchison and Allende both are mostly these amino acids and alcohols. No, not the alcohol you want to drink, not ethanol, but the chemical class of chemicals that are called alcohols, which are organic compounds. Now, we know of thousands of amino acids. Only 20 of these form the base, the chemical basis of life on Earth. Just 20 of them. Protein, for example, is built of chains, long chains of amino acids. So you flex a muscle, you got your protein in there. That's a bunch of amino acids. Now, so far, 70 different amino acids have been found in Murchison. Some of these are the same ones that occur in Earth life forms. There are no proven fossils yet. There's one of the specimens, one Russian fellow claims that he's found some fossils, but his pictures are not convincing. Nonetheless, this presence of these amino acids in the carbonaceous chondrites appears to indicate that the building blocks of life occur throughout our solar system, perhaps even the rest of the universe.